lesson essential question today is how do we solve linear systems graphically? We're also going to look algebraically. Everyone should have picked up the sheet in the back of the room when they walked in. Okay, so let's take a look at the next page here.
I don't want to do that.
Solve the system of equations below, then graph the two equations on page 1.3. So, here we have a system of equations. Basically, what a system of equations is when you have more than one equation and you're solving for x and y. Okay? We're going to look at how to do it two ways. We're going to look at how to do it graphically, and we're going to look at how to do it algebraically. All right?
I like graphically better.
Like graphically better. Okay, so the good thing about this is you can always do it graphically to check your solutions. Unless the exam says do it algebraically, then you have to follow through all the steps. But you can always check and make sure you're right graphically. Okay? So, here's our first two. Now, this is integrated algebra. This is review. Okay, so I've got y equals 2x plus 4, and I have y equals negative 3x minus 1. I want to solve for a variable here. Yes, Brianna?
Don't you have to make them equal?
Very good. Brianna says make them equal to one another, because they both say y equals. So what we're going to do is we're going to set these equal to one another. We're going to do it algebraically first, and then graphically. So 2x.
Can't you just enter that in the graph and get...
We're going to do that after. We're going to do it both ways. 2x plus 4 equals negative 3x minus 1. Okay, so algebraically first. All right, so what's going to be my next step? Now we're just solving an equation, right?
Minus 2x. Yes.
You want to get the 2x over?
Yeah.
No, that's the 3x.
Whichever one you guys want to do. Add the 3x. Okay, so if I add the 3x to this side, what am I going to get on the left-hand side of my equation?
5x plus 4 equals negative 1.
Very good. 5x plus 4 equals negative 1. Could you have done it the other way?
Yeah.
Yeah, absolutely.
Who wants negative 5x?
Okay, next step. Subtract 4. So what do we get? 5x equals negative 5. Excellent. Nice job, you guys.
So it's going to equal negative 1, x equals negative 1.
Yes, very good, Josie. X equals negative 1. How do we do with that, okay? Good?
Yeah.
Okay. Are we done? I know x. What else do I need? Y. Okay, remember, a system of equations, the solution is a coordinate point. When we graph it, we're going to see that, okay? So we need x and y. So how am I going to figure out what y is if I have x? Plug it in, okay. Doesn't matter which equation?
No.
No. All right, so we have,
Right? So
say that again?
Do the first
You
one.
go on without the negative numbers.
Yeah, I would do that. Y equals 2 times negative 1. And this is not a calculator page, so you do have to do this with your brains.
Ooh, me too. This is challenging.
Okay, so we get negative 2 plus 4, which gives us a solution of y equals 2. Now, who can tell me which way I'm going to make you write your solution?
Negative 1, 2.
And how are you going to put that negative 1, 2?
And those things.
In what things?
I don't know.
Bracket. The squiggly bracket?
Not the squiggly brackets. Remember, a
Bracket.
solution is a point. A solution is a point. Parentheses. Okay, so negative 1, comma, 2. That is your solution. Maybe you'll write, I would write solution so you know, or SOL. Okay? How do we do with that?
That was a really
That was
serious
good, right?
question in any shape or form.
Good. So this is an algebraic solution. Okay? So now let's look graphic. Are you ready for graphic?
Those are the good videos. I don't like the graph. Thank you. That's how I'm ready for it.
All right, so go to the next page. And what we're going to do now is we're going to do this graphically. Okay, everybody see this f of 1 of x, f1 of x down here?
Negative.
Okay, f of x is the same thing as what you guys are used to seeing y equals. This is f of x equals. The reason it's f of x is because we're dealing with functions. Okay, so first thing you're going to do is you're going to type in 2x plus 4 right down there. And what do you think you're going to hit to make it graph?
Down.
Enter.
I had down in the graph too.
Okay. So we've got, what? 2x plus 4. So this is a linear line, right? Linear function. What kind of slope does it have?
Positive.
Positive. And what is the slope?
No, it's going up.
What's the slope of this line? Look up at the equation. 2. What's the y-intercept? 4. Okay, so that's just a little bit of a review. Okay, so notice the little f of x thing disappeared down here. And I want to put in another line, right? Control G.
I didn't. How do you guys know that?
Calculator class.
Yeah, but I don't remember that.
Don't you just go down to the arrow and click it?
Does it work?
Yeah.
Okay, Control G works
I
too.
just pressed down and I kept it up.
Okay, so we've got Control G, and I want you to enter in the next equation, okay? And Joey, I'll be right there. And then hit enter. So, do we have our 2 graphs on there?
Yeah.
We're good to go? Now what we need to do is find the point of intersection. So where do you think I'm going to go to figure out the intersection? Menu, good.
Points and lines.
Let's see if it works.
Get a point.
Points and lines. Where do you see?
Intersection point.
Intersection point. Good, so go to 3. Intersection point. So everything that we're looking for is in that menu, okay? So now what you're going to do is, you see how it highlighted one of them? I want you to click on one line,
Oh, I remember this from the old country.
and then you're going to go to the other line and click on that one. And notice what automatically pops up.
-2.
And notice it puts a point on it. That's your intersection point. It labels it for you on the graph. Your solution is -1, 2.
Which is what we got. So then this checks it for.
All right, so that's graphical. Any problems with that? Now, here's the issue. On the Regents exam, you will be asked to graph these lines. Used to be that we'd be able to go to the table and pull off these points and plot them, right? There's an easier way with this graph. So I want everybody to go back to your menu. I want you to go down to trace. Why don't you go to trace settings? Okay. See how it comes up automatic? I want you to click on that, and I want you to go down to enter value and make it a 1. Why do you think I'm making it a 1?
So it goes up.
Yes, it goes by once. Okay, then just click, go down to hit tab. It brings you down to OK and click it. Okay. So what you've done is you've changed your trace settings so it goes by intervals of 1. All right. So now go back to menu. Down to trace. And do graph trace. You see that little spider thing? Okay, so what you're going to do is you're just going to move it, and you should see,
Goes by 1.
if you click, you move and click, and move and click, and move and click. Do you notice what it's doing?
I'm not moving right.
You hit your left and right on your nav pad. Is it doing it now? Okay.
Looks like after we get trace.
Does everybody see how you can pull up the values? So that when you graph these on the Regents exams, you'll be able to do that, correct?
That's amazing. You can see 'em.
Okay, so to get to the other line, if you're moving along the line, you're hitting your left and right. To get to the other line, you just hit up or down. It'll transfer you to the other line. Okay? So I want you to put some data values on each of these.
I think you're so crazy.
What do you mean?
Like all these different spots.
I'm just moving around with my nav pad. Just clicking over and up and down, and it brings you to different places.
So on the regions, how many different points would you need?
How many points do you need to graph a line?
3.
You should have 3 on each line. Yes. You can use 2 because that will give you a line, but I prefer that you have 3, and 3 that are labeled. Okay? Because if you graph one point incorrectly, that is a graphing error, and that is a point off. So it's important that you do this part correctly.
How do you transfer a different line?
So what do you guys think about that? Are we okay with that?
Yeah.
Pretty neat? Okay, go to the next page. How is the point of intersection related to the algebraic solution of a system of equations?
I don't
They're
know.
the same. The point of intersection is what? Not the vertex. It's the solution. So what you're going to write in there is you're going to say, okay, the point of intersection is the solution to the system of equations. No. So the point of intersection is the solution to the system of equations. All right, so We've got our statement in there. You guys ready to go? Alright, so let's take a look at the next page. On the next page, the lines from a system of equations problem have been disconnected from the intersection point. Use up and down arrows to move the lines so their solution is at the intersection. Alright, so here we are. Over here is your line of intersection, or your point of intersection, 5, -1, okay? So what you're going to do is you're going to use these arrows up and down to try and move these lines so that their point of intersection is at 5, -1. So take a few minutes to play with that and see if you can get them to line up.
That's fun.
Oh, so we're basically taking buttons together.
So you click on the 5, -1 or something?
Click on the arrows.
Click on the arrows. See the arrows here?
Which one will beat you?
So you just gotta go from arrows to arrows, just clicking stuff.
John knows the answer.
It's not true.
Yeah, it is.
That's not.
The arrow keeps moving and making you click
I
on it.
know, mine does too.
I keep pressing the OK button on my arrows and when you try to make
Wait, we
them
have to get
all
them to
go.
intersect?
Yeah,
See, it's gonna be intersect at 5, -1.
right.
My arrows going crazy though. I can't get it.
Yeah.
Right?
Mine's bouncing around a little bit too.
Mine just got like to the point where
Oh
I
my
can't.
god, this is really getting me.
Yeah.
Right now. Oh.
That was a weird.
Why does it
noise.
say certain words in this class? Stop moving.
I wonder if you
Okay,
could.
I'm gonna show this down to the boss.
I already showed that calculation.
So if you can't get it to move anymore,
Wait,
try
wait.
try working with the other one.
Oh, that was.
People were talking about my mom, people were talking about my girlfriend. Today is not my day.
Alright, so you
I
guys
do
played
have
around a
my
little bit.
heart's desire.
These arrows were kind of bouncy. But you notice what I did? What happened to my second line?
It's right there.
No, I got one.
Why do you think I only see one line?
Yes.
Yeah, my values for A and C and B and D are all the same, correct? So if I make it the same line, what do you think my solution becomes? We're intersecting at the point 5, -1, but what happens if I have a line laying on top of a line? Two lines, same equation, right? So what is the solution if you have, not just one, how many points are the solution? How many times do they intersect? Infinite. So the solution is what?
Wait, why does they infinite?
Because if you have two equations, they could be different equations, but they're the same line, correct?
Yes. We had two lines.
I know, but what we did is we changed A, B, C, and D. See how it's all matching up, and now we have
We were supposed
just
to.
one line? We could have. We're
I
just
mean,
taking-
mine's so like this.
Good. Mine is just a different way. So there's
Oh,
other ways that you can do this, okay? So we're able to play around and kind of manipulate those numbers to get them to intersect. That's what I was going for. All right, so to record the equation of the lines, solve, let's skip over this. All right, on the next page, two lines are graphed. Use the up and down arrows so the lines represent the system of equations with no solution. Then move the lines so they represent a system of equations with infinite solutions. So we just kind of talked about that, right? So here are my lines. I want to make it so there's no solution. And then I want to make it so there's infinite solutions.
No solution, they would just not intersect.
Say it again.
No solution, they would just not intersect.
Did everybody hear him?
Oh, I heard him.
If there's no solution, are the lines ever going to intersect? I know. It's okay. So if there's no solution, the lines are never going to intersect, correct? So tell me about a line that never intersects. Give me an example of two lines. Say it again. Parallel lines never intersect. Why?
They're the same direction.
They have the same direction. They have the same slope. So what kind of lines never intersect?
Parallel line.
Parallel lines. Okay. So infinite solutions. Let's talk about that again. What's it going to look like if there's infinite solutions? One line. They're going to lay over the top of one another. Are we okay with that? Good. Move on.
Wait, why don't you have your lines intersecting at 5, -1?
Say it again.
Your lines are intersecting somewhere different. Am I in the wrong spot?
Don't know. All right. So to write the equation of the line, this is in the form y equals mx plus b, right? Or bx plus d. Either way.
There's a.
Okay, so
Then I find slope. Black.
let's look at the next page. Give me an example of a line, of two lines that would have no
It's not my
solution.
next page.
Scroll on and find it. Give an example of two lines that would have no solution. Yep, go ahead, John. No, because they would have the same slope. Oh, yeah, that's right, sorry. Y equals x plus 1, and y equals x plus 2, right? So, those would have no solution, and the reason for that was why? They don't intersect, and why is that? Why don't they ever intersect? What do they have in common here? Same slope.
So why is that y equals, why is it like that? Y equals x plus 2?
Because these two lines, they have no solution because they're never going to intersect. The reason they never intersect is because they have the same slope.
Oh.
Okay. All right, so what's something going to look like if it has an infinite solution? Y equals x plus 1. Another example of this would be 2y equals 2x plus 2.
How do you get down there?
Control tab. All right, so let's look at the next page.
There's an next
There is, that's it?
Yeah.
Wow! We got the whole lesson! Good, so we have some practice. That's what the worksheet is for. So take that worksheet out.